continue now. So we're on to the next chapter. Yeah, we're finished trigonometry, aren't we? Yeah. Unless you want to do more graphs. What? Okay, next now. Yeah, calm down. Contain yourself. Right. So for the next chapter, what we're going to be looking at are graphs, but rather special lines on these graphs. So for example, if I have a graph like this, we could have a line that passes through it at 2 points, or we could have a line that passes through it at 1 point. If the line touches the quadratic once, we call this line a tangent. If it passes more than once, we call this a secant. Secant line, tangent line. So the difference, or rather, to make it clear, a tangent line meets the curve once. Locally. What do I mean by that? So what I mean by that is, if I have a graph like this, here, if I draw this line, let's try that again. I still call this a tangent because it meets it once, locally. I know you might say, well hang on, if I continue the line up here, it'll meet it up, it's really, hang on, draw that nicer. Right, here. Ugh. There, once. So I call this a tangent because it meets it once. But you might complain, well, if I continue the line, it meets it again. I don't mean that when I talk about tangents. I only mean in a small area it meets it once. Not like this. Okay, so that's what I mean by local. Okay. Let's have a look now at some examples. Can I scroll down to here? Yeah. Okay, so it's a small example to get you started. Check if the line y equals minus 2x plus 3 is a tangent line to the curve y equals x squared minus 2x plus 3. How do you think we can check this? What might we be able, or how might we check this? How can I check if this line is a tangent to this curve?
Make them equal.
Yeah, why? Why make them equal? Yeah, you have the idea. Is that what you were going to say? Or you have another idea? We haven't done that yet. That is true, but we haven't done it yet. So, this is how you can check. The simple way to check is just to solve. If we get one answer, then what does that make it? A tangent. If we get 2 or more answers, we get a secant. So I'll give you a minute. I want you to solve this and solve this together and tell me what we get. Okay, so check if it's a tangent or a secant. I want everyone to solve now. Yeah.
I can't leave after 1.
Answer.
A and A.
Yeah. Answer. Okay, have people solved it yet? So, what's wrong? Have you solved it? You've solved it? How many answers does it have? 1. Plus minus 0 is 1 answer, dude. Alright. So, good one, good one. You stick to the maths. Okay. Let's solve. So I'll get x squared equals 0. So x equals 0, y will then equal 3. 1 point. That means the answer is it's a tangent. Let me use my graph program to draw this. Okay, so the first one was y equals, what was it? Minus 2x plus 3. And the second one was y equals x squared minus 2x plus 3. Solve this, no, not solve, sorry, plot. There's the quadratic, and now here's the line, and it should meet it once, which it does. So you can see it's a tangent, not a secant. That's what the graph looks like. Yeah? Get the idea here? Okay. So, next now, well, I'll just give you a second to write this down and then we'll go on to the next one. Okay, can I scroll down? Okay. Alright, next now. I'll give you this time the quadratic. Well, I gave you that last time as well. So here's the quadratic. X, y. Y equals 9x squared minus 3x plus 4. And I'll give you a point here. I'll say, let's use the point 0 to make it easy. And then we'll draw a tangent line at 0. Ugh. Tangent at x equals 0. And this line has a slope. And I want you to think about how we can maybe find the slope of the blue line. Note, before you start, some people know what this is. If you know what this is, you're not allowed to use it.
But if I don't know, I can use it.
How can you use it if you don't know it? In other words, I'm not asking you to do this. I want you to find the m, but not this way, because I haven't taught you this. So you need to think of a way to find the m. Yes, think about that for a minute. See if you can find it. Maybe some people might want to draw a graph and try to guess it from the graph. Or maybe you have another idea. I'm just as an example. You tell me your idea. Think about it for a minute. We'll see who has the smart idea. Do you really think you have it, Lee?
No. Is it 0?
Does that slope look like 0? Huh? Yeah, but how did you get it? I told you not to do that. You're not listening to my instructions without using the derivative.
I did, but
But
I cannot think of anything of it.
well, you're not going to learn this way. You need to really think hard now. Is there another way to do this without the derivative? Yeah. You must think me some monster that I'll give you a question that you can't do. Yes, there is. Any ideas?
Yeah, n plus 4 equals to 4. So n equals to 0. Yeah.
I'm a 0?
Divided by m. Oh, no, never mind.
Yeah, good. Yeah, you have an idea? What's your idea?
The line y equals mx plus 4.
Good. Okay, so the first thing is this line here is going to be y equals mx plus c. Now, you know that this point here is 0, 4. Because I tell you it's 0 and you can see it's 4. And this point is also on the line. So that goes in here to get the c is equal to 4. So at least we know the line is y equals mx plus 4. But I didn't want the line or the c, I want the m. So now, what's the next step?
Make them equal.
Yeah, we should solve these. And how many answers should there be? 1, because it's a tangent. So we have 9x squared minus 3x plus 4 equals mx plus 4. So we get 9x squared plus minus 3 minus mx plus 0 equals 0. What type of equation is this? It's a quadratic. How many answers should it have? It should only have one answer. You've seen this type of problem already. The discriminant, is 0 because it has only one answer. So you know that minus 3 minus m squared minus 4ac should equal 0. That means minus 3 minus m should equal 0, so m equals minus 3. Yes, I told you you can do it. How come you kept getting 0, Lee? What were you doing?
I substitute the value x and y inside when I'm doing 9x squared minus 3x plus 4
Oh, so you kind of had the right idea?
Not really.
Okay. Right, so I don't think anybody got this, so please write this down carefully. But there are other ways to do this without using the derivative. So there is a way you can roughly get the answer. Any other ideas? No? No other ideas? No ideas, okay. Can I scroll down? Alright. Let me give you a little hint. Another way to do this. If you want to find m, you can use this formula. Yeah, but what's the problem with this formula? Why can't we use it? Yeah, we only have 1 point. We need a second point, which we don't have. But we can use this point, which is close. It's not going to be perfect, but it's close. If I move a little bit to the left, let's say x equals minus 0.1. I could use these 2 points. Now, it's not going to be perfect because is this a tangent or a secant? It's a secant because it'll be actually that line going through the 2 points. Let me draw that again. So it's close. Let's test it out. x2 minus x1 and then y2 minus y1. Now we have to work out y2. So if you just take this number and put it into here. Let's see. y2, can someone type this in? 9 minus 0.1 squared minus 3 times minus 0.1 plus 4. What is this, please?
We are making x2 equal to 0, so y2 should be 4.
Oh, did I have this on the wrong side? Thanks. Right, what did you get here for y2? 4.21. Are you sure? I don't know. Guys, I'm waiting here. What do you get when you type this in on the calculator?
4.39.
Thank you, that sounds better. 39.
Yeah.
So when you divide this, 4.39? So 4 minus 4.39, that's 0.39. So we get minus 3.9, is it? Is it? Yeah? I don't know. It's not quite that close. But how could we make it better?
Minus 0.9.
Yeah, make it smaller, yeah. Maybe 0.001. So let's check this out on the calculator. Okay, so on the bottom we'll go 0 minus 0.001. We'll go a little to the left only. And on the top, we have 4 minus, and then we need the other value. Minus 0.001. Hold on, don't confuse me. But thank you. Squared minus 3 times minus 0.001 plus 4. Yes, it's getting better. So this is another way we could find the tangent. We could actually use 2 points, but the points need to be close together. And if we get closer, it gets better. Nice. Yeah. Okay, so what I'll have you try now . Okay. Try one U V W X and 2 D E F. Problem? Okay. Huh? You have a problem? And it's sitting to the right of you? I have a problem too. They're sitting in front of me.
Is it called with a computer?
Yes. I did say day for 2. Huh? Donna, can you put the light on, please? Thank you. Are you cold?
Yeah.
You look cold. Bruce, is that heater on? The heater?
Yeah.
It's on? Feel it.
I see.
It's on? Are you sure?
Hot.
Thank you, Bruce. Thank you for that. Lee, are you working? Stop distracting Monica, she's trying to work.
Oh, you're distracting me.
What's wrong? Be strong.
Losing 10 years.
What? Lee, are you up to trouble again?
No. I'm making one, I'm not.
True, true. Now, before you go, you can leave the coursework in my office. If I'm not there, you can just leave it on my desk. A teacher will put it on the desk for me to get later, okay? At 4 o'clock, I'm going home. If I don't have your coursework by then you lose 10%. You understand? I hope so. Okay, go. Yeah.